Hi, welcome to the Physics Experience. My name is Mike Randall. Today we're going to be talking about electricity and why science makes sense. So what we have here is a Van de Graaff generator. This makes static electricity. Looks something like this. Looks pretty impressive, doesn't it? So here's the question for you. Is this dangerous? Or specifically, is this more dangerous than the electricity we get out of a wall outlet? Common sense would say, well, that looks pretty scary. That's got to be the dangerous one, right? Well, ow, you can hear that. It's shocking me, but I'm not going to the hospital. So this is actually harmless. But the electricity that comes out of your wall outlet is deadly. Don't ever, ever, ever stick anything metal into a wall outlet, okay? So how can we understand this? Well, common sense says the scary thing is dangerous. But if you understand a little of the science of it, you'll understand why that's not a problem and that is. So electricity is made of little teeny tiny things called electrons, okay? And that's electrons moving around. So that's all that electricity is. So what makes electricity dangerous? Well, you need a combination of things. You need how many electrons, and by the way, in technical terms, that's called current. And then how hard are those electrons being pushed? That's called voltage. Think of it like a waterfall. So if you're standing at the bottom of a waterfall and water's hitting you on the head, are you going to get killed? Well, it depends. What if it's like a 1,000-foot waterfall, but it's just a little tiny trickle of water coming over? Yeah, it'll hit you, it'll sting, but it won't kill you. Okay, but what if it's a 100-foot waterfall, but you're standing at the bottom of Niagara Falls, where there's a whole lot of water coming over? So that would kind of smush you up, right? So the height of the waterfall is like voltage, okay? And how much water is going over the waterfall, that's like the current. So you need it's the combination of the two. This is about 250,000 volts. Volts is how scientists measure how hard the electrons are being pushed, okay? So this is 250,000 volts. It'd be like a really tall waterfall. But the number of electrons coming in that spark that you saw earlier, very, very few. So they measure the current in something called amps. So millionths of an amp of current. So tiny little current, a lot of voltage. It stings. Not going to send you to the hospital. But your wall outlet, it puts out 120 volts. So it's like a much shorter waterfall, but it puts out 15 amps of current. So it's that combination of voltage and current. So you need to keep that in mind, but also keep in mind that sometimes what seems like common sense doesn't always give you the whole picture. It's really important to understand science so that you can actually really figure out what's going on. Don't necessarily go with what your first guess is at something. It's good to guess. It's called a hypothesis. Do make your guesses, but then do a little bit of science, do a little research, ask around, find out if your guess is correct or not, okay? That's what scientists, by the way, do all the time. Anyway, thanks for stopping in today. We look to see you again soon.